the very beginning, this is the part that people sometimes struggle with, is how we refer to different terms. This thing right here in a sequence, I'm going to erase the series for now, but a series will be when we add them up. We'll do that in a minute. For right now, for just this sequence right here, we call this first term A sub 1, and that will refer to the first term of any sequence. This is A sub 2 in a general way, meaning it's the second term. It doesn't have a value of 2, but it's got a value of 11. It's got a number of 2. It's kind of like, folks, it's kind of like the difference between domain and range. Domain is these guys, these numbers here below these A's. That's a 1, 2, that's the domain. So the third term, we call it A3, and its value, its Y value would be 14. The second term, when you're talking about number 2, being the domain, the X value we plug in if you want, its value is 11, and the first term's value is 8. And we refer to them this way with commas in between when we're talking about sequences. So this would be the 4, 5, let's see, 3, 4, 5, 6. This would be A6. And if you put a comma and then a bunch of dots like that, and we don't know what sits up here, we're wondering what that is, that's a question mark, this would be called AN, meaning the nth term. That's how we refer to it. We don't know which term it is. It's up there a ways. We just refer to it as the nth term. This is the 6th term. It's pretty clear, right? But if we go a long ways up and we don't know how far we're going up, then the last term that we write here, we would call that the nth term. If after that, or anytime you have the dot, 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 it means it could go on forever, especially if it's just left at the end. It means this pattern continues forever. Okay, so that's how we refer to things. That's what they're showing you in the core concept on the top of page 410, is how to refer to these things with A's and subscripts. Now look at example 1. And we have this thing, we have a sequence defined this way. AN equals 2n plus 5. So the nth term, any term you want to do, is going to be 2 times that term number plus 5. Now, doesn't that look like a line to you? Y equals mx plus b. I mean, we've got different variables in there, but it's a line. Okay. So is this, by the way. If you plotted these points, because you start at 8, and then you would go up 3. As you went out to the next one, you go up 3, and then up 3, and then up 3. What it is a line with a slope of 3. Anyway, this first sequence that we're looking at here is 2n plus 5, and it says write the first 6 terms. Pretty soon, after you've written the first 2 or 3, you see the pattern. You can write the others without even doing any figuring, really. The first term means A1, which would be 2 times 1. Notice these match. Plus 5, which is 7. And A2 would be 2 times 2 plus 5, which is 9. And so the next term is going to be 11, 13, 15, 1, 2, 3, 4, 5, 6. There's your first 6 terms. You can see the pattern pretty quickly because all we're doing is adding 2 each time. 5 plus 2 is 7. 5 plus 4 is 9. 5 plus 6 is 11. So it's every time you put a new number in here, you've got 2 more terms, 2 more numbers. Okay, here's another one. It's a little bit strange. This is a different way of writing it. F, it's in function notation. And f of n is equal to negative 3 to the n minus 1. That's a different look. And this is also, by the way, this is a line because it looks like mx plus b. This is exponential. Pretty clear, I think. This is exponential because it's got a number raised to a variable power. And we find the first 4 with several terms of this. Rather than writing a1, we write f of 1, which would be negative 3 to the 0. You see that? And that would be 1. And then I find f of 2. So that's all we're doing here is we're replacing n, just like we did over here. This n right here we replaced with 1s and 2s as subscripts. Now they're just f of the next number. And we replace it up here. It's going to be negative 3 to the 2 minus 1, which is 1. You see what's going on? F of 3 is, and maybe the pattern isn't quite apparent yet. We got negative 3 to the 2nd, which is positive 9. Yeah? You seen it? Okay. F of 4 is going to be negative 3 to 1 less than 4, which is 3, and that's negative 27. I got 4 terms there. Can you tell me the next 2 without writing this out? What would it be? 81. 81 and
81 times -3.
okay,
Which is
negative 243. Notice that the signs alternate. That's because every time you have an odd power on a negative, you get a negative. Every time you have an even power on a negative, you get a positive. So it's alternating as you go along. Y'all see it? Not too bad. Look at example 2. It says, describe the pattern, write the next term, and write a rule. So now they're going to give you a sequence of numbers like this, and you got to write this rule. You got to go back and write this thingy that goes with it. That can be a little bit tougher. Okay? So it says, describe the pattern, write the next term, and write a rule for the nth term of the sequence. So we've got -1, -8, -27, -64. Get rid of this up here so I can stay on this board. Somebody read me that pattern again. What was it?
-1, -8, -27, -64.
And I want you to write the next term. Yeah, can you distinguish the pattern here?
They're all perfect cubes.
They're cubes. Do you recognize those as cubes? This is 1. This is 1 cubed with a negative on it. 1 times 1 times 1. This 8 is 2 times 2 times 2. 3 times 3 times 3. This is 4 cubed. The next one will be? Which is? -125. So we accomplished part of it. We got the next term written. We recognized in trying to figure out how we could figure out the next term and looking at these and going, oh, they're cubes. That should help us write the nth term. What is the nth term of this? If this is A1, A2, A3, A4, A5. And what you're looking for is a pattern between these numbers and these results. Negative n to the third. Do we put that in parentheses or not?
Yeah. Just that, like, no.
Doesn't matter. Because if you do this and raise it to an odd number, it'll be negative anyway. Because then when you raise it, you'll have 3 negative signs, which is a negative, right? If you left it like this, you'd still have a negative sign on the cube. So in this case, it doesn't matter. Sometimes it does, but in this case, it doesn't. Y'all follow that? Okay, there's another one. Can you read that one to me?
0, 2, 6, and 12.
What's the next term?
24.
36.
That's a tough one, huh?
Yeah,
It's like 1 times 2, so 2 times 3 is 6.
Wouldn't it be 20 because you're just
0
going
times
up?
1 is 0.
Sorry? Rachel, what?
It'd be 20 because you're just going up. You add the 1, so it'd be, so the 2 times 1 would be 1 times 2, 6 is 2 times 3, 12 is 8 times 4. Anyway, it would be 4 times 5 because it's just going up a number.
You think this is 20 then?
Yeah.
Okay. Now, if you think that's 20, can you give me an nth term? Because you were talking about this, and I liked it. But this is A1, A2, A3. We have to come up with a link between these numbers here and these results here.
Would you multiply it by n plus 1? Wait, no.
Do you do 2 to the power of like the nth term, so it'd be like 2 to the power of 2 and that's added?
2 to the power of 2?
Oh wait, no, 2 times 2 and that's added, and then 2 times 3, and then that's added. 2 times 4. Cause like, 2 times 4 is 8, 8 plus 12 is 20. So, 2 times 3 is 6.
Lots of conversation going here, and I think you're right, Rebecca, except for you're not quite stating it right. Anybody else have another thought? Go ahead.
Well, you have to do your nth term, and since now one, or, yeah, when you go, you'd have to go your nth term minus 1, but then that's multiplied against your nth term.
So
So your nth term.
So your nth term times the one before it?
Yep.
So we're talking about these guys right here producing these, right? And you're saying if I took 1 times 0, that would give me this one.
Yeah.
And if I took 2 times 1, that would give me this one.
Yeah.
And if I took the next one, which would be 3 here times 2, would give me this one.
Yeah.
Now, did you get that off the page or did you come up with that? Did you get that off the solution?
I was like thinking that way. I did look at the book to like help me like get that little last of it, but
Yep.
that's where I was going.
Okay, well, it is the fact that we've got, I mean, this product is this product is this product is this product is this. And to get that 0 to start out, you've got to take, you're right about the -1 here, because you've got to have a 1 here and a 0 here.
That's where
To
I
get
was
the 0.
confused.
Okay, and that's what you were, when you were doing this, you were going against the 4 times the 5 and then the 5 times the 6 will give you the next one. So what's the next one, by the way? 30. Notice also that the gap gets wider by 2 each time. Does it? No. It gets wider by the next even number.
Yeah.
Anyway. Okay, so these are the kind of, you gotta sit and think and look and think and think and look and try to figure out how they're related. The main idea, folks, is to figure out how these numbers are generated from these some way. These numbers at the subscripts. These have to make these in a certain way. Okay, that's called the rule. Okay, let's look at example 3. I have no idea why anyone would do this. They might do it with a set of cans, but I don't think I'd ever do this with apples. Maybe. I don't know. Unless I had something to go around the outside of the bottom row, because it seems to me like the whole thing would collapse. But here's what you're doing. It says you're working at groceries, example 3. You work in a grocery store and are stacking apples in the shape of a square pyramid with 7 layers. Write a rule for the number of apples in each layer, then graph it. Notice that they say at the very top that you should start with the top, which has the smallest number of apples, so that your sequence goes up. It's always easier if your sequence goes up rather than down. So if the first row, in the first row is the very, very top apple, how many apples are in that row? 1. Okay. What's in the next row? 4. And then? 9, right? In order to have the slots to stack it up, and then? So you're starting to see it, right? What's next?
25.
25, what's next?
36.
Yep, and then?
45.
Is that 7 rows?
Yeah.
Okay, that's a list. That's a list of the number of apples in each row. That's what they asked us to do. Okay? Write a rule for the number of apples in each layer, then graph the sequence. I really don't want to do that, but here's what they mean by graph the sequence. I don't want to get too high anyway. It's 1, this is 2, this is 3, this is 4, and on up. These are the x values, folks. So if you're going to graph this thing, we're going to go 1, 2, 3, 4, 5, 6, 7. And it's going to get out of control pretty quick, so I'm going to number these by 10s. 10, 20, 30. This is going to be, this is x equals 1, and the first value is 1. So it's going to be about right there. The next one, that's the x value. We go over to 2, and we go up to 4. It's about right there. And then we go out to 3 and up to 9. That's about where the 10 is almost. And we go out to 4. That's 16. That's a little more close to 20. I don't know if I should probably spread those out a bit more. And then 25, which would be right in the middle here, and then 36, and then 49. Can you see that it's exponential? Well, it's maybe not exponential. I don't think it's exponential. It is quadratic. How come? How do you generate all of these terms? Yeah, it is n squared. Whatever n is, you square it. So this is a parabola. This is the right side of it. Because the function that generates the next term is Standard parabola, n squared. Okay, moving on. I gotta hurry. Okay, summation notation. Now we're gonna go to series, which is to sum them all up. In other words, what we would be asking now is, how many apples do you need to make this stack? Now we're gonna add them all together, right? Not how many is in each row, but how many are you gonna need to finish the stack? Okay, so that's a number. We're gonna add them together. And this is where it gets a little weird. You might want to go back and read that core concept a little more slowly if you can't remember what's going on when you run into this. It says, in example 4, write each series using summation notation. Notation is the way we write things in math, and this is a new one, and it's weird, bizarre looking. Summation notation. It is I'm going to draw it correctly the first time, and after this, I'm just going to draw it quick. It is the Greek letter capital S. That's what it looks like. In the future, you'll see me just go like this. People think it's an E. It's not an E. It's an S. And it stands for sum. And what we want to do is, instead of writing out, 50 terms, we want to be able to summarize it in a very small space and still get the idea of what we mean. This means to add everything together. And the first one we want to put in summation notation is 25 plus 50 plus 75. So this is what we're looking at. 25 plus 50 plus 75 plus ... I don't even know how many they want us to do. Oh, up to 250 it says. So that's the series that we're looking at. It's a series because it's got plus signs in between, which means we're going to use this sum. And here's what we do. We write n equals usually 1, almost exclusively 1, to something up here, which we'll decide in a minute. And what goes here is the formula generator for this, as though it were a sequence. So if I put commas in between those, how could I write a rule for generating the next term? If this is A1, A2, A3, and I don't know what this is, but we'll figure it out. N times 25?
Yeah.
So 25n. Which one will this be if it's 25n? Which term will this be? The tenth. Good. So this is a 10. And what that tells us is we're going to sum from n equals 1 to 10. Going increment. 1, 2, 3, 4, 5, 6, 7. And what that means to us is we're going to take 25 plus 50 plus 75 plus 100 plus 125 plus 150 plus 100. Somebody get a calculator, start on this. 75 plus 200 plus 225 plus 250. It's big. It's not huge, but it's big. I mean, it adds up pretty quick.
1,375.
What is it?
1,375.
1,375. That's what we say. This idea, summarized like this rather than like this. That's what this right here, this right here is what this means to do. So this is equal to 1375. It starts at 1, it goes to 10, and this is our generator. You got to look at the patterning up there to figure out what your generator is going to be. That's what this means to do this. You following me or not? You put 1 in for n, then 2, then 3, then 4, then 5, until you put 10 in for n, and you add up all the results. Okay, let's look at the next one. It is 1/2, 2/3, 3/4. Boy, this will be ugly. One half plus 2/3 plus 3/4 plus on up here to what? Is it then, or is it just?
There's also 4/5 and then.
Oh, 4/5, and then it just goes on. Okay. All right, I'll put that in there. 4/5 plus ... means there is no end. Or at least we don't know what it is. We're supposed to write this in summation notation. We usually start down here, n equals 1 to, how far are we going to go? Not infinity, just n. We just don't know what it is. Okay? This time we don't have a number. Is that how we're going to let us do it? They say infinity. They do say infinity. Okay. That's fine. It means that n could go as high as we want. But we're only trying to write this in summation notation. We really, I don't think they're actually gonna ask us to add those up. Can you figure out a generator for all of these terms? This is A1, A2, A3. What will AN be up here ways? The nth term, how are we gonna write that formula for that?
It'd be 9/10.
What?
9/10.
And you're closer to.
Oh, wait.
Not 9.
2 6.
If I get up there to the nth term, I have no idea what that term is. Can I write that term in terms of n? Aren't these top numbers n?
Yeah.
What are the bottom numbers?
Plus
N plus 1. That's all. Oh. That's how you write the idea to add all of those up that way. You see? You kind of follow that? All right, moving on. Example 5 says, find the sum of the series. This time they give it to you in summation notation, so now we got to think about that. It's going to be, they're using k this time, it doesn't matter what variable. K equals 4 to 8 of 3 plus k squared. So sum as k equals 4. Notice this isn't a 1, it's okay. K equals 4 to 8 of, what was it? 3 plus k squared?
Yeah.
Okay. I mean, okay. What's the first term here? I'm not actually going to write a number here yet. I'm going to actually write out what we would do to find that number. It would be what? Which is? Oh, you want to do, okay, we can do that. 19, I'll buy that. Because it was 3 plus 16, right? What's the next number we're going to plug in? 5. And what's 5 squared plus 3? We put a plus sign here because we're adding. What's the next number we put in for k? 6. 6 squared plus 3 is? 39. And then? 7 will be next. 49 plus 3 is? 52. And the last one is when we put 8. When we finally put this in, then we're done. So this will be 64 plus 3, which is 67. And then we grab our handy dandy calculator and add them up. We will learn later how to actually do this with a formula, but not today. Not right now. We're just going to add them together. 205? Okay, so I told you series are numbers, and this number is 205. Okay? Try example 6. I think we're going to make it. It says how many apples are in the stack in example 3? So we add up. We just, by the way, what would the summation notation for that look like? N equals 1, 2. Look at it again, see. 7.
We want 7.
And what are we going to sum up?
N squared.
N squared. So that would be 1 plus 4 plus 9 plus 25, 36, 49. Grab a calculator, write that out. By the way, this one actually has a formula. I jumped right over it. The core concept on page 413. Notice it says on the third one, the very last one of that core concept, it says the sum of squares from 1 to n is n times n plus 1 times 2n plus 1 over 6. In other words, we could have found this rather than just muscle this through. We could have said n, which is 7, times n plus 1 times 2n plus 1. That would be 2 times, that's the nth term we're talking about, would be 14, 15, divided by 6 should also give you the answer.
Wait, how'd you do that?
What is this number here? Anybody?
Oh, it's 140.
140? Okay. Does this one also give you 140? If I take the 2 out of here and the 3 out of there, I get 20 times 7. Yep. 140.
How'd you do the whole fraction?
There's a 2 and 6, which I canceled out of here. There's also a 3 and 6, which I canceled out of here.
No, like how'd you get it? Like
The formula?
Yeah.
Oh, it's written in the book. you don't get to discover that. That's a horrible thing to try to discover. It's a number theory question. They're just handing it to you. Do you understand how I did it though? N is this number right here. This last one you're doing if you start at 1.
Okay.
So 7 plus n plus 1 plus 2n plus 1 divided by 6 gives you the sum of squares if you're going to sum squares. In other words, if we were going to go from n equals 1 to 50, you would definitely want this, not that. But what is short? It's 6 1 after the other. Okay, I've assigned the big ideas math assignment if you're doing it in there. By the way, if you have not yet scored above 76 on this, or 75 or better on this test, even though you just took that quiz, you still have to do this assignment on paper until I get that score adjusted. Okay, so if you're below 75 on your test score so far, and that's with the 5 points added. Take the score you got, add 5 points. If that's still below 75, you got to do this on paper. So here it is. Paper writers, here we go. 5, you ready to write? Those of you doing it on paper? It's 5, 6, 8, 9, 15, 16, 21, 23, 32, 35 to 37, 41, and 43. Obviously, those were handpicked. Okay, I hope this was useful. Bye.